Thank you for watching this Hexagon Geospatial e-training module, Simplifying Spatial Models Using Apply Index. In this module, you'll learn how to use Apply Index, a single operator used to quickly apply many types of remote sensing indices, or band ratios, to your image. Using Apply Index is an alternative to building an explicit spatial model for each type of index that you want to apply to an image, and allows you to preview each result immediately. To emphasize the difference, let's build two spatial models to calculate a vegetation index, in this case NDVI, which indicates the health of vegetation. In the first model, you'll see how to select and manually set each operator to create the formula and set the preferred bands. In the second model, you'll see how to use a single operator to do the same thing. Finally, you'll learn how to use the second model to apply other categories of remote sensing indices, such as water and snow detection. First, let's begin with method 1 to build the index formula. For this example, begin by loading a Sentinel-2 13-band image in ERDAS Imagine. In the Contents panel, deselect 2D View number 1. From the File tab, select New, Spatial Model Editor. In order to create an NDVI image, you'll need to write the formula for NDVI into the model. To calculate NDVI, the software will take digital numbers from the near-infrared and the red bands of the image. The formula used to calculate NDVI can be seen here. It's calculated by taking the near-infrared band minus the red band and dividing it by the near-infrared band plus the red band. Now create a spatial model to represent this formula. In the Operators panel, type raster input into the search bar. Click and drag the raster input operator into the canvas. Double-click the raster input operator. The raster input dialog appears. Under File Name, click the arrow and select Sentinel-2 subset.img. Under Read As, click the arrow and select Float and click OK. Now define which band in the 13-band image is the near-infrared band and which is the red band. Return to the Operator panel and type Band Selection into the search bar. Drag and drop two band selection operators onto the canvas. Right-click on the upper band selection and select Rename. Rename the operator NIR and click OK. Repeat for the bottom band selection and rename it R for red. A quick look at the SAF file for Sentinel-2 13-band image shows the red band is band 4 and the near-infrared band is band 8. Select the NIR operator. In the Properties panel, click the Band Range Value field and type 8. Now select the R operator. In the Properties panel, click the Band Range Value field and type 4. As noted in the formula, now look for subtract, divide, and add operators to place in the spatial model. Return to the search bar in the Operators panel. Enter subtract for the subtract operator. Drag a subtract operator onto the canvas. Click the raster out port for NIR and connect it to input 1 port of subtract. Connect the R operator's raster out port to subtract's input 2 port. This represents near-infrared minus red. From the Operators panel, search for and drag a divide operator onto the canvas. Connect subtract's output port to divide's input 1 port to represent the divide operation for the formula. Next, add the near-infrared and red bands together. Search for, then drag and drop the add operator to the canvas. Connect the raster out port of NIR operator to add's input 1 port. Connect the raster out port of R operator to add's input 2 port. Connect the add's output port to divide's input 2 port. This completes the formula. Now preview the results. From the Operator panel, search for and drag a preview operator to the canvas. Connect the output port from the divide operator to the preview input port. From the Spatial Modeler tab, in the Execute group, click Preview. 2D View number 2 opens. In the 2D view, the image is a representation of an NDVI version of the original image. From the Contents panel, deselect Spatial Model Editor number 1 and 2D View number 2 to close the editor and the view. Now use the apply index operator to build a simplified model to create the same output results. The apply index operator automatically calculates the formula and sets bands when selecting the index. Select File, New, Spatial Model Editor. From the Operators panel, search for raster input. Drag in a raster input operator, then double-click it. Under File Name, click the arrow and select Sentinel-2 subset.img. Under Read As, click the arrow and select Float and click OK. From the Operators panel, search for Apply. Drag an Apply Index operator to the canvas. Select the raster inputs port raster out and connect it to the raster in port of Apply Index. Double-click on the Apply Index port labeled Sensor Name. Click the Sensor Name arrow and select Sentinel-2 13 bands. By selecting a particular sensor, the process will automatically select the proper band numbers that correspond to the index calculation that you select next. Click OK. Double-click on the Index Name port. Click the Index Name arrow, select NDVI, and click OK. Note that building the formula for the index calculation is no longer necessary. From the Operators panel, search for Preview. Drag a Preview operator to the canvas. Connect the Apply Indexes raster out port to Preview's Input 1 port. From the Spatial Modeler tab, in the Execute group, click Preview. A 2D view opens, displaying the NDVI image. The Apply Index operator can be used to quickly calculate a variety of different indices. These include other vegetation indices and other remote sensing indice categories such as water, snow, and mineral detection. Double-click the index name port labeled NDVI on the Apply Index operator. After choosing an index, you can easily go back and view others. In the Index Name dialog, click the arrow and select WBI and click OK. This applies a water band index to the image in the preview window. Water band index results are good for analyzing canopy stress, fire hazard conditions, and cropland management. Double-click the WBI port. In the Index Name dialog, click the arrow and select WVWI and click OK. This is the Worldview Sensor Water Index, which is used to detect standing water or shadows. Now double-click the Index Name port. In the Index Name dialog, click the arrow and select NDSI and click OK. Now a normalized differential snow index is applied to the image and can be used to differentiate and to map snow and ice-covered areas from non-snow and ice-covered areas. As you can see, you can use the single Apply Index operator to calculate many different indices using one simple model, without having to manually build the required formulas or define the required bands. Thank you for watching this e-training module from Hexagon Geospatial. For more e-training, please visit hexagongeospatial.com/etraining.